Hi, I'm Laura. Welcome to Pretty Powerful Pandas, a mini-series where I'll walk you through the most useful, elegant lines of code in Pandas, whether you're just starting out or you want to level up your data game.
For today's video, we're going to be looking at custom functions using .apply. Now, Pandas, as we know over these past few weeks, is pretty powerful, but sometimes you kind of need to build some of your own definitions because the things you do in your teams are very specific to what you do. So instead of using all the functions that are available through Pandas, we're going to create our own today. So we have been working with the global superstar data, so I've collected that. Last video we looked at time date, so I've made sure that that is still working, and we added a column called lead times. If you are unsure about that, just pop back to the last video and review that. Otherwise, what I'm going to do is I've just created a new data frame called DF, and that's just based on the orders of the profit, the lead time, and the ship mode. So that's where we're starting with today. So what I would like to do is I'm going to create our very own definition today. So we're going to do a definition and we're going to call it classify profit. And I'm going to do it on the value of P. Now P here is going to stand for the value of the profit for each row. So that's what that is. When we're creating a definition, we've got to put this, and then when we move into the new line, we automatically get tabbed in Pandas and Python. Now this is really useful because when we put in our function, which in this case is going to return the word hi, if the value of P is greater than 100, else it's going to return no. And then I now can come out of that tabbed section, and anything that has been tabbed is part of that definition, classify profit. So if I had multiple lines, that would all be part of it, but I just have a single line. It's nice and easy. So I'm going to take my data frame and I'm going to create a new column called profit level, and this is going to be based on my old column of profit. And what we're going to do is review each of the values of profit, and for every single one we are going to apply, so that's where our .apply comes, apply this function. So now when I pull my data frame, this time I'm going to just look at the top 10 rows. There we go. When I apply that, I've now got a new column called profit level. And this profit level is looking at the column of profit, and for each of the values, P, within that, if it is over 100, I get a yes. So here we go. And if not, I get a no. Nice and easy. So these are really useful. For example, as you see, if within your team you need to put a flag up, or you need to have an extra column based on something else. So that's how you can write definitions. Now definitions are really helpful if you're going to be pulling them again and again. So if throughout my script I'm going to be coming back to classify profit in multiple different things, then it's really good to actually define it and set it up as your own function. However, most of the time we're probably not actually going to do that, and we're just going to create an off-the-cuff rule, and once you've used it once, that's it, done. And to do that, we're actually going to use lambda. So I'm going to create a new column called fast delivery, and it's going to be based on the lead time in days. The lead time in days, and I'm going to .apply this time. I'm going to give us a bit more room so we can see, and I'm going to do lambda. Lambda, there we go, and you see it turns green, so it knows it's a function. And this is, lambda just means a throwaway function, so instead of me creating a brand new one and giving it a name, I'm just kind of going to create it off the cuff within the apply itself. So because we're in lead time of days, I'm going to say D is my value here. And I'm going to define that as, please say yes if the value in question is less than or equal to 2. Else, can you say no? Okay, so what we've got going on here, and let's call this again. So we've got a new column called fast delivery. What it does is it takes the lead time in days and it applies the function. So we've created our own kind of off-the-cuff, throwaway, disposable rule, basically, where it takes each of the values of that column. So here's our D. D is 2 in this case. And we're going to say yes in our new column of fast delivery if D is less than or equal to 2. So we've got a yes, we've got a yes, and then for this one we've got a no because it is not less than or equal to 2. So that's what we're doing there. So lambdas, even though they kind of look a bit complicated, they are just the kind of quick and easy version of doing a single throwaway function instead of defining your own function yourself. Great, so that was per column. We were just looking at a single column, but sometimes we want to add conditions where we're looking at multiple columns at once. So I'm going to call this one VIP, and we're going to class it as a VIP order if we apply, and this time we're going to get a few different things. Now, because I'm working over lots of different columns, I've actually got to say that I'm working over the axis equals 1. Remember, in pandas, like we spoke about a few videos ago, our indexing begins at 0. So all the rows are actually index 0, and then the columns are index 1. So I've got to define that that is axis 1, and that means we're going to do our lambda. Lambda, there we go, it turns green, we know we've got it. And this time, instead of a singular value of a single row, we're going to use the whole, sorry, a single column, we're going to use the whole row. So I'm actually going to write it as row. Row is going to be the thing that we look at. So the lambda is going to go through the whole row, and we are going to say yes as a VIP if our row is, let's give it profit is greater than 200. And then and, so I'm going to put this in kind of a bracket so we know it's this and this. So we want two sorts of things going on here. So if the profit is over 200 and the lead time is less than or equal to 2. Okay, so if these two conditions hold true, this and this, then this new VIP row is going to get a yes, else it's going to get a no. Now at the moment this is in red, so don't forget to put your comma, and that'll turn that into non-red, which means it's all good to go. Okay, let's pull the top 10 of our data frame again. It's thinking, had a little thinking time there. So now we have our VIP row and it follows those rules. So profit has to be greater than 200. So no, yes, this one is greater and the lead time is less than or equal to 2 days. So that gets a yes. The lead time here is less than or equal to 2 days, but profit is not that. So because both conditions don't hold true, that one's got a no. So there you go. We can now use the dot apply and apply it over the whole way across the row through multiple conditions for multiple columns, which is great. Now, you did see that actually that took a little bit of time, didn't it? It didn't just happen. If I run it again, it has a little bit of thinking time. I mean, it is maybe less than a second, but it does have thinking time. So part of being a coder is realizing actually when the thing that you're using might not be the best way of doing things. And pandas, don't get me wrong, I love it, it is amazing, but actually if you've got a huge massive data set, using dot apply might not be the most efficient way of doing things. So what we're actually going to do is we are going to import NumPy as np. So NumPy is kind of what pandas was built on top of. It's the number Python, it's all kind of how all the maths works behind it, and it is very efficient because it uses vectorization, which is incredibly fast. So if you find that actually what you're using, the function you're using, is not that quick, please look elsewhere and see if you can find a quicker one. So we're going to use fast delivery, but this is vectorized. I'll just put a little v there to show that it's different. And this time I'm going to pull np, so we're going to pull our NumPy and use .where. and we are going to say where the lead time. There we go. Just going to pull that down. So where the lead time, let's put in data frame. There we go. The data frame of the lead time is less than or equal to 2. So that's what we're calling where that. And we're going to say yes if true, and if not true, no. So we don't even have to put if this is true, then yes and no. You just kind of say true and then false. So here we go. Now if I pull our data frame head, and look how quick this goes. Ooh, instant. So let me just show you again. If we do the non-vectorized version and we're doing .apply, just watch how long this takes. Thinking done, and then the vectorized version done. So even though pandas is wonderful, sometimes it is more efficient to actually use other things. So we've gone back into kind of the original NumPy and worked with some vectorized functions, which is great. You can also do a .map. So if I really quickly show you here, I'm very conscious I've run over my 10 minutes, so I'm going to copy and paste this. You're not watching me type, but I've got a priority mapping where we use a dictionary. So I've got my key and my value. So I've got same day, I'm going to put in the number 1. If I see first class, I'm going to put the number 2, second class 3, standard class 4. So I create a new column called ship priority. So if the ship mode, what it does is it maps it from the priority map. And if I run that again, we can see that's really quick as well. So sometimes .apply is wonderful, especially when you're building your own functions, and sometimes .apply is not as efficient, and we use .where or .map within NumPy itself. So there you go. That's Pretty Powerful Pandas and what Pandas was built on, some NumPy. I hope you enjoyed that. So go and make your data pretty powerful.